Hello, welcome back. I spent the last lesson going over how to find stationary points. Remember, if 2, 3 is a stationary point, x equal to 2 gives a maximum or a minimum. The maximum or minimum value is the value of y. So, and I have done some examples how to find stationary points. I also discussed a common sense approach when it came to trigonometry, a special question on trigonometry I did. So for the next 2 lessons, hopefully, I want to concentrate on verbal questions or physical situations, mathematical modeling. You're given a physical situation and you come up with a mathematical model, use calculus to solve the model, and then apply your solution back to the physical situation. Yeah, this year, of course, your teachers have taught you and you've done many questions, so I'm just taking some for example. So in other words, applications of differentiation to practical problems. On maximum and minimum. I might leave this title for the next 2 lessons so that it saves me time writing the title. Alright? That's taken me 1 minute. By the way, my name is Sosale Mohana. I am a math teacher with considerable experience, over 50 years. 50 years and a term, and I have taught mainly A-level maths and further maths, of course, further pure maths, A-level maths, mechanics and statistics, and then A-level pure maths, but further pure maths and further mechanics, not further statistics, and I don't do discrete maths either because I've not done it before, and stats I've never learned in my life. Of course, if you want to go into analysis of pure maths, you want to do groups and rings and vector spaces, fine. Mechanics, yeah, simple harmonic motion, moment of inertia, stability of equilibrium, fine. But statistics, chi-square, normal distribution, hypothesis testing, each one of you is better than me. Okay, right. Coming back to this, let's take some verbal questions. What I'll do is I'll write the question here and then I'll solve it here. These are typical examples. Number 1, the sum of 2 numbers, 2 positive integers is 40. What is their greatest product? So this I could do by guesswork. I could make it 400, I could make it 4,000. It's a concept I am trying to teach you, right? So whenever a question is given like that, you convert it using mathematical language. You're being given 2 positive integers. Do I know the positive integers? I don't know. So therefore, I will call, let the integers be x and y. You know, the problem I have, or I get, your teachers too will get irritated, is if this question comes in the exam, some student will write p plus q equals 40. Yeah, we know what he or she means, but please define it. What is p, donkey? Q, monkey? No, you know their integers, I know their integers, but you didn't tell me. And my job is not to find out what you're thinking. It's your job to demonstrate and tell me what I'm thinking. I mean, I'm talking as a teacher and a pupil. So when your teachers give a question, when you want to write down at A level or even at university, you need to define. So what have you been given? The sum. So we have been given s equals 40. So x plus y is 40. That information is given. Then what is the greatest product? So product is xy, You are asked to find P maximum. Yeah. So now I have converted that into symbols and mathematical language. To find any maximum minimum, I need to differentiate. But if I find dp by dx, I can't, because there's a y sitting there. At the moment, later on we will learn implicit. If I do dp by dy, I can't, because there's an x sitting there. So in questions like this, you do not continue with differentiation or maximum minimum until you have only one variable. Then how do I get rid of x or y? That's why this piece of information is given. So either I can write y as 40 minus x, or I can write x as 40 minus y. Always dy by dx. So let's use x. So therefore from there, y equal to 40 minus x. So p is x times 40 minus x. Oh, I've come across students trying to use product rule with this. Please think for a moment. It's a very simple expression. 40x minus x squared. It's easier to differentiate that than use product rule. Now that I only have a p and an x, I can use maximum minimum. So what do I do? dp by dx equal to 40 minus 2x. How do you find maximum minimum? Find dy by dx. Equate it to 0. Find x. 2x equal to 40. X equal to 20. Right? But how do you know it is maximum? Unless the question says you need not test or verify maximum minimum. There is always minimum 1 mark to prove it is maximum. It's your job. Another question says, the question doesn't say don't bother finding testing for maximum minimum, but you have to show it because you are asking for they are asking for the greatest value. So d squared p by dx squared is 40 gives you 0 minus 2. Whatever it looks, normally you put the value of x you got into d squared y by dx squared. If it is positive, it is minimum. If it is negative, it is maximum. Yeah. But here there is minus 2. There is no x. So whatever might be the value of x, d squared p by dx squared will always be maximum. Because it is negative, therefore maximum. I want to find maximum product. So I can do, x equal to 20, so y is 20. So the product maximum is 20 times 20, which is 400. Yeah. Good. Now, does that ring a bell? Remember, when we did quadratic equations, I told you if the coefficient of x is negative, then it's a cap, or the parabola's vertex is upward, is vertex upwards, or how would I put it? It's like a inverted U, or a cap, or a maximum. And you see, it supports what we learned in coordinate geometry. In fact, the concept of what we told you in quadratic equation actually comes from this. It's not the other way around. These are typical 5544 mark questions. I'll take another question, which is 9 minutes, so I think I will quickly do this one. The product of two positive integers is 64. What is their least sum? Look, in the previous case, you are given the sum, you are finding the product. So depending upon the condition, the value will be either least or highest. Same story, So explain yourself. Let numbers be x and y. What information are you given? The product. So xy is given to be 64. You're asked to find the sum is x plus y, and I want to find least s. To find any least or any highest, I need to differentiate. I cannot differentiate because if I say ds by dx, what will I do with the y? X gives you 1, but please don't say y gives you 1. If I do ds by dy, what will you do with the x? So I repeat, anytime you have to solve questions like this, you don't start differentiating unless you have only one variable. So therefore, I need to get rid of x or y. From here, let's get rid of x this time. X equal to 64 over y. You could have done y equal to 64 over x. I want to get out of this x always. So s is equal to 64 over y plus y. Can I write it as 64 y power minus 1 plus y? Because then it's, please don't use quotient rule. I have seen students for a simple thing like 64 over y or 64 over y squared using quotient rule. And they forget derivative of 64 is 0 and they get the wrong answer. So please be careful. Do not, if it is simple, write it as a power minus 1. So what is ds? This pen is also gone. So what is ds over dy? Is 64 minus 1 y power minus 2 plus 1 equated to 0. I get minus 64 over y squared plus 1 is 0. Multiply through by y squared minus 64 is 0. Y squared is 64. Y is 8. Ah, sir, but you told us always that you should, whenever you take square root, write plus minus. I agree. And if you point that out to me, you are 100% correct. Why did I do it? I know they are positive integers, so I don't need the negative square root. So if you want to write plus minus 8 and say if y is greater than 0, therefore I'm going to take only 8, perfect. But we accept at a level that you can analyze and write the correct answer. If y is 8, what is x? 64 over 8, which is 8. Again, what is the least sum? How do you know that the answer you got for y will give you the least sum? How do you know it? Yeah, I don't have to tell you. Good. So, d squared s by dy squared. Look, when I differentiate this, I get minus 64 y power minus 1 gives you plus 64 y power minus 2. Oh, it was a minus 2, was it? Oh my God. I am sorry. Plus 64, minus 64 times minus 2 y power minus 3. So that is plus 128 y power minus 3, which is 128 over 8 cube, positive, so minimum. So therefore, sum least is x plus y, which is 16. Understood? In fact, when I did A level, that given the product as a p squared, and you must show that the sum is the least when the values of each digit is p and p. Instead of giving all that, it works. But fortunately, questions like that do not appear anymore, and you should be grateful to your examiner boards because they made life much easier these days when compared to what it used to be before. I always tell my students, even though there are new concepts that are coming, the standard and the level of difficulty has gradually come down. All right. I'll just do one more question. This is a diagram. All right. That's a wall. That's an enclosure. And ABCB is a rope of length 400 meters. Let's say 100 meters. I don't read the whole question. An enclosure in the form of a rectangle is made using one side of a wall and the other three sides being made out of a rope of length 100 meters. What is the greatest area of the enclosure? That's the question. So in other words, I don't know. This is a rectangle. So I can call this as x, and I'll have to do that. Okay, I'll show you. Suppose I call this as x. Then you get this will be 100 minus x over 2, 100 minus x over 2. Now in terms of work, don't you think it is pretty complicated? Why bring fractions? So this is where we use our common sense. So let's assume that the sides of this rectangle are x and x. The total length is 100. These are x and x. So do you agree that is 100 minus 2x? Fortunately for me, I don't have to worry about a second variable. I've just used one variable. So therefore, area is x times 100 minus 2x. And I want to find maximum area. I only have one variable. Please don't use product rule. Differentiate. dA by dx equal to 100 minus 4x. Equate it to 0, x equal to 25. Yeah? So again, you must prove it is maximum, is minus 4 less than 0 maximum. So therefore, if x is 25, that's a 25, that's a 25, that's a 50. So maximum area is 25 times 50, 1250 meters square. That's a very practical problem. Maybe you're a farmer and you want to make an enclosure where you can keep a pen for your sheep. Then you got that rope. Of course, the farmer will not sit and do it using calculator and then using differentiation. But he knows that normally he will say 100. So if I do 50 and 50, it can't work. So by trial and error, they will know. But you as a math student, you will be able to help them. If he asks you that, look, the best thing will be put 25, 25 and half, put half on side and quarters on the other two, it will work. And it does. Okay. I've took some simple questions. In the next two lessons, I'll take a more complicated question on practical problems on maximum minimum. Okay. I'll see you next time. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.